All right. Let's get started. So I'm Ben. I like to make games for fun sometimes, mostly mods for games. So kind of taking an existing game and then kind of modifying it to add new features, change old ones, kind of stuff like that. Usually multiplayer sort of games. So that's just a little bit about me. I've been using Unity for, I don't know, 4 or 5 years or so, just off and on whenever I kind of want to make some sort of small game. But games do take a while to make, but it's a lot of fun. It's very rewarding to make games. So I would highly recommend it, if you have the chance, which is right now. And so today we'll be using Unity, which is a game engine for game development. It's free, but then it has different tiers if you want to use it for commercial use too, but you can just download it right now and use all the features. So make sure to install it before the workshop, which is going on right now. And then you'll also need Visual Studio or some other IDE text editor to edit some of the scripts that we'll be working with. And feel free to ask questions in the chat or unmute yourselves. I'll be watching the chat throughout the workshop. And I've pasted the workshop resources in the chat, as there's a couple things that we're going to be using that aren't included in Unity, just a texture and a font that you'll see later. And so today's agenda looks a little something like this. We're making it a golf game. You know those games on Steam, like Golf It or Golf with Friends? Those are Unity games. And so we're going to kind of be making one of those. It's going to be a lot of fun. We're going to work through it together. And we're going to end up with something that looks a little bit like this. So you can see there's the ball in kind of the bottom right-ish, and they got to go around that log and then up that little hill into the hole. And that's going to be the extent of our game. And so we're going to start with a little intro to Unity. I'll open it up, give you guys a tour of the editor, kind of what everything does. And then we'll jump into level design. So we're going to be designing that entire level first. And then after that, we're going to work on adding gameplay, namely through scripting and different components of game objects, which we'll get into in a second. And scripting can get pretty complex, so I've tried to keep it as simple as possible since it's the beginner tutorial. So camera systems are incredibly complex. So I tried to make a camera system that was just super simple, easy to use, that we could get through pretty quickly. Ball movement, so how do you fire the ball? Can you adjust your power? How does that display on the screen? All of that stuff. And then hole detection. So when the ball goes in the hole, how do we detect that? And then how do we display some text on the screen to say, hey, you got it in the hole and you win or something, right? And so let's get right into it. So we got Unity open right here. This is the Unity hub. This is just like all of your projects. So if you want to make a new project, you can hit new. And this guy will pop up. So we can call it golf game. Choose where you want it to be stored. For me, it's just here. And we're going to be selecting a 3D template. So that just gives us some default settings in the project that are useful to us. If you're making a 2D game, you probably want to go with the 2D template. And then there's a bunch of other different templates that you might want to try out too. These are just starter packs. It doesn't really matter what template you start with, because you can always modify everything about it. So if you start with a 2D game, but then you realize you want to do a 3D game, but you don't want to make a new project, you can just kind of modify your existing project to be 3D. So let's go ahead and hit create. And it'll take a couple seconds to open up. It's on my other monitor, so you can't see it opening, but I'll drag it over once it's open. Because it usually takes like a minute or two to create a new project depending on your PC. All right, so now we are in, and it should look a little something like this. Let me know if it doesn't look like this for you, because then we'd have to fix something. But it should look like this when you choose the 3D template and you just open up your project. And so there's a lot of different windows and things here, so I'm going to start by explaining some of them and some of the main ones that we're going to be using. So over here in the hierarchy window, It's usually on the kind of left side screen. You can see the current scene that we're in. So a scene in Unity is kind of like a level. It contains all sorts of different objects and different things. And so you can load a person into that scene, do all the stuff there, and then maybe if they get to level 2, you could load them into a separate scene. So they're kind of just like levels in a game. And so within our scene, we have these 2 game objects. And game objects in Unity are kind of just things that exist in the world. And these vary wildly between, what they can be. So for example, we have a main camera here. So this is going to be the camera in which the player sees through when they play the game. And so if you look at the scene view right here, you can see the camera that we just selected. It's right over there. And if we click on the game view right next to the scene view, you can see what the camera sees. Right? It just sees nothing right now because we haven't created anything. But by clicking on the camera here, we can actually see a camera preview, which is exactly what it's looking at right now. And so we're going to get into some keyboard shortcuts here and there as well, which I'll be using throughout the presentation. So in case you forget any keyboard shortcuts, feel free to just put them in the chat, and I will remind you of what they are. So one really useful one is when you select an object, it might be kind of far away, because as you can see, this looks pretty far away, but we want it to be a little bit closer. So while your mouse is in the scene view, you can hit F, and it'll kind of zoom over to your object. And so that helps you kind of locate where objects are and get a better view of them. And now to move around in the scene view, you can hold middle mouse click to drag the view kind of forward, backwards, up and down, kind of like that. And if you don't have middle mouse click, you can also use the mouse, the hand up here, and you can also drag it around. So middle mouse click kind of moves it around. And then if you hold Alt, it'll come with this little eye icon. And if you click and drag, you'll rotate around. So this is great for just looking at it at different angles. So middle mouse click moves, and then Alt, you can rotate around. And then you can also zoom in and out, which is your mouse scroll wheel. So if you want to zoom into this and really look at it closely, you can zoom in. And now you can see kind of how the camera movement works in the editor. So if I wanted to go to some space in my level, we could do that. Any questions so far? All right. Cool. Yeah, so this is our camera, and every game has at least one camera because the player needs to see through something. Without the camera, the player doesn't see anything. And then once you've selected on a game object over here, like the camera, you'll see in the inspector window all of the different components that it has on it. So every game object by default has a transform component, and that basically tells the game some info about it, about where it is in the game world and how it looks. And so each transform component has a position, rotation, and scale. So position is just where it is in the world, X, Y, and Z coordinates. The rotation is how it's rotated. So, is it upside down? Is it 45 degrees this way? Kind of like that. So you can see if we adjust the X a little bit, the camera preview rotates up and down with the camera. And I did this by just clicking on the X and then dragging either way. And you can kind of increase and decrease it easily. So that's how we would rotate an object. Same way with movement. We kind of move it back and forth. And then scale is how large the game object is. So let's say we had a sphere. You wanted to scale it up. You could adjust the scale parameters here, and it would become larger. And then for this game object, because it's a camera, it has the camera component. And so the camera component basically tells it that it is a camera that the player is going to see through. And then it has all of these different properties that we can adjust. But we won't be getting too much into these properties. But all you need to know is this is a camera, and players can see through it. And as you can see, we also have a directional light by default in this scene. And if we zoom in on it with F and maybe scroll a little bit, we can see that it's kind of pointing downwards at an angle. And so a directional light is kind of like a global light everywhere in your scene that's just coming down or up or whatever angle you make it in the scene. And so moving it around actually won't affect the lighting at all, but rather its rotation will affect the lighting. And so as you can see, it's dark because it's pointing up, so it's not lighting underneath it. But for our purposes, let's just point it downwards. And as you can see, it has another component on it called light, which gives it all of those light properties and makes it a light. And let's set the color of it to white, because the yellow is not my favorite, and I just like white for the lights a little bit. But of course, you can change this to whatever you want. If you want to make it red, you can make it red, and you'll see how that affects how the game looks in a little bit. So feel free to play around with any of these things. All right, so we've got a camera and a light. So now let's start to build out our scene. So we're going to start by making kind of a border around an area that we're going to use for our golf game. Because usually golf games have borders so that your ball doesn't go out of bounds, but sometimes it still does. So let's create some of those. So right over here in the hierarchy window, I can right click, go to 3D object, and then cube. And there's our cube. So it's another game object, except this time it's a cube instead of a light or a camera. And you can see over here, it has a couple different components that make it a cube. It has a mesh filter, which is kind of like the geometry of the cube, so just like a cube geometry, and then a mesh renderer, which tells the game how it's supposed to look when we look at it in the game. We're not going to get too much into that, but we are going to be adjusting some things. So we want to make 4 borders like we saw in the picture I posted in these slides. So let's go ahead and do that. And we can do this by actually just adjusting the scale of these. So if I start adjusting the X scale, you can see it just expands out. So let's make the X scale 20. And so now it is 20 meters across, because all of these units are meters, by the way. So it's 20 meters across. And now let's make another one. But first, let's actually rename this so we know exactly what it is. So it's not just a cube, it's a game border. So let's call it game border. So if you click on a game object and you click on its name again, you can rename it. So we can call it game border. And so that's looking pretty good so far. And now let's make a few more borders, right? So we could just right click 3D object cube again, and then manually change the scale, or we could actually just duplicate it. So in Unity, duplicate is just Control D. So once you select your game border, hit Control D, and it'll make another one for you. And then we can drag it outwards, just like that. So then we easily created another border. And so when we're making this, actually, we do want to make sure that these are properly aligned so that the border is very nice and even. And one way to do this is to click on your border and check out the position. So the position is all these kind of crazy numbers, right? So let's just reset all of these to 0. And so now it's perfectly on the floor, or is it? It's actually halfway into the floor, the invisible floor, because there's no floor here. It's actually halfway into the floor because it's like internal position is halfway down in the object. So you can see where this indicator is, that's where the actual position is. So it's halfway down. So in order to correct that, because we want it to be kind of on top of the floor, we can set its Y position to half of what the Y scale is. So the Y scale is 1. So if we set Y to 0.5, it'll be directly on top of the floor, which is exactly what we want. And we can sort of do the same with this one, but we can space it out exactly 10 meters or 20 meters away from the other ones so that we can start to make a perfectly square game area. So we can go ahead and reset it a little bit. And then we can set the Y to 0.5 again. Drag it out this way. And as you can see, at -20 is going to be about where we want it. So now they're evenly spaced, and you can sort of start to see that we're filling out this square right here. So now let's make the other ones. So we can duplicate these again, drag it out, and here's where you kind of have a choice. You can either rotate it a little bit on the y-axis and make it go like that, or you could just change the scale. Instead of x being 20, you could change z to 20. So I'll show you that too. So you can change that back to 1 and then z to 20. You can see it perfectly goes out just like that, which is exactly what we want. So we can again drag this out right over here. Zoom in, let's take a look. And let's make sure it's aligned. So we can kind of look at these position values over here. X seems to be about 10. Z is also -10. And now it looks like it's almost right there, except there's these little gaps right here. So we can just fix that by expanding the Z just a little bit more. And so that looks like it's going to be about 21. So now we have a nice looking border on this side. That's pretty good. Nice looking border on both sides. And then we can use our duplicate trick again to just copy it over to the other side. So click on that one, Control D, and see that, oh my gosh, it's huge. So we're gonna have to adjust that. There's a couple settings that we'll need to adjust for that. Usually terrains are used for very large scale games, open world games. But they're also great for golf games because then you can make kind of convex, contour, nice curves to your golf landscape. So with our terrain selected, let's go into terrain, the component, and then you can see this little cog right here and go into the settings. And if we scroll down a little bit, you can see mesh resolution is one of the sections, and then terrain width and terrain length. And that's 1,000 by 1,000 right now. But we just want it to be probably 20 by 20 because that's the size of our game area. So let's change that to 20 by 20. And that looks like it's going to fit. So now, if we scroll back up to transform, we've got to move it into the center there of our game area. Let's go ahead and do that. Yeah, so we can move the position left and right, kind of like that. And then move it right into place. And then, of course, we can even these out. So that's perfectly where we want it. Just like that. And so now you can see we have a nice area for our game to take place. We're going to build a little level in here so that the person can golf and make it into the hole. And this is also pretty nice if you want to make multiple levels, because then you can just kind of copy all of these game objects and then reuse them for your next level and just modify some things within it. And so let's do a little bit of organization right here, because right now we've got all these kind of free-floating game objects in the hierarchy, but we want to keep it nice and organized. So if we right-click in here, we can select Create Empty. And what that does is it just creates an empty game object. Where'd my gizmos go? I'm very confused. Unless I click something. I did. Give me a moment while I find my gizmos, because usually there's the, it pops up. Give me one moment. Okay, so the issue is, yeah, so when you click the settings icon here in terrain, it'll get rid of all of the other stuff that you might see generally, and that's because it just gives you all the terrain tools. So we can actually just go back and exit that, and we should be able to do this now. Let me see. Strange. Let me see. Yeah, I'm missing the transform handle that I used to have. Where'd it go? Okay, I will fix this. Do not worry. I'm gonna try reopening Unity real quick. That is very strange. It's all right. Things like that happen. But let me know if you have any questions. There we go. We're back. Okay, cool. So now that they're back, we can go back to editing stuff. So now we've got our terrain in there, and now we need to edit our terrain a little bit. Let's add a little kind of mountain like you saw on the slide earlier, so that the player has to, hit the ball over the mountain, get it in the hole, but then if they overshoot, it goes to their side. It's kind of a fun little challenge. So to do this, we can select our terrain object and then go to the paint terrain. It's the second button here. You can see we have all sorts of different brushes of different shapes. You can also add new brushes with your own shapes, but for now we're just going to be using this built-in brush 2 with this kind of faded texture. And so that's going to create a nice gradient for us to use. And so if we zoom in a little bit here, we can try it out. As you can see, whoa, just by holding left click, you can see we've created some very large kind of shapes here. And that's not quite what we want. We want a nice gradual terrain and hills. And so let's Control Z to undo that. And how we can adjust that is by adjusting the opacity a little bit of the brush. And also, let's just the opacity. You can adjust it very low so that it doesn't have as much impact. So now you can see it's a lot slower. And there's a lot more terrain stuff that you can definitely look into, but this is just a little intro. And so let's make our little mountain. And for our example, we probably don't need to actually drag very much unless we want to create some nice walls like this. Instead, we can make our brush a little bit bigger by adjusting the brush size here to maybe 5 or 6, maybe 6. You can see it has this size. Then we can just kind of raise the terrain a little bit in area. You can see it kind of looks like that. And now we just need a hole at the top. But you can also see that it doesn't look quite that great. And that's also because of the terrain resolution. It generally thinks that you're going to make this giant terrain, so smaller things like this aren't really detailed. And so we can fix that by going to the settings again, and then scrolling down to the detail per patch, which is 32 right now. We can change that to probably 64. It's a little bit better detail. All right, so we've got our little terrain here, a little hill. And now let's make a hole at the top. We can change our brush size down to probably 1, nice and small. And then instead of left clicking, it says we can hold shift and left click to lower the terrain. So if you want to decrease the terrain height, we can do that. So holding shift and left click, you can make a little hole at the top. Try it out, see what you make. All right, make something that looks kind of nice. That looks pretty good. Try to get the ball in there. That's not bad. If you want to see some of the wireframe, you can click this button up here that says shaded, and then hit shaded wireframe. And now you can see exactly kind of all the different vertices and how it actually looks, in case it's a little difficult to see right now. That's looking pretty good. I like that. So I think we're pretty much done with our terrain at this point. But now let's make the terrain actually kind of green, because right now it does have the checkerboard pattern, but we want to make it green. And in the workshop resources, I've included a checkerboard pattern that I'm going to be using in this. You don't have to use it. It's just a slightly higher quality version than the default Unity one, because as you can see, if we zoom in here, it's kind of blurry at the edges and it's not very crisp. So I made a slightly better looking one, and so you can use that. So I'll import that right now. That's grid.png in the workshop resources folder that I just pasted in chat. You can go ahead and download that and then save it. And then all we have to do is drag and drop to import it. If we just drag it, drag it right down there, you can see it imported our grid image. And so now, with that grid image, we have to create a material. Materials take textures in. So this is like a texture right now, just kind of like an image. Materials take that texture and allow you to define different properties on it of how it is affected by light and different things in the scene. So if you want it to be really shiny, you could turn up the shininess or metallicness. If you want it to be smooth, there's different properties for that. If you want it to be transparent, you can also adjust that. So let's go ahead and create a material. So if we right click down here in the assets view, you can hit create, and there's a ton of stuff here. Now it's a little overwhelming, but we're going to go to material. It's right here under audio mixer. And let's call this new material floor, because we're going to be using this for the floor. So with the material selected, you can see over here shader standard. So I don't know if you've heard too much about shaders, but shaders are, kind of pieces of code that help you define how it interacts with everything around it. So different shadows, light sources, things behind it, things in front of it, just how it kind of looks to the player who's going to be looking at it. But for now, we're just going to do standard. And you can see main maps here, albedo. We want to choose something for that, because down here, this is what it currently looks like if you put this material on a sphere. It has no texture yet, so it's just kind of blank. So let's apply our grid texture to it. So over here, you see albedo, and there's a little circle next to it, and that allows us to select the albedo texture. And so if we click that, this little menu comes up, and we can select our new grid or the old grid if you don't want to import the one that I have. So we can select this grid, exit out, and now you can see the grid is applied here. But it's not green yet. We want to make it green. So in the albedo map, we can just click on the white and change it to green. And so now you can see our preview down there in the bottom right. It's looking pretty good. Let's just adjust it. Not too bright, like that's pretty bright. Maybe down here in the grays, darker greens. That's looking pretty good, somewhere around there. And to apply the material to the terrain, all we have to do is drag it on. So we have this floor material, and just drag it. Okay, didn't want to drag, apparently. That's strange. That's very strange. Oh, Yeah. Okay. So in order to apply the material to your terrain, I don't think you drag it on apparently. But if you select your terrain and then you go to the settings cog again, you can see material here under basic terrain section. And it's using the default terrain material. And we can change that. So we can click this little circle next to it, which brings up the selector again. We can select our floor. Oh, there we go. Look at that. Except it doesn't look quite right, does it? We want it to have a lot of checkers and not just kind of one checker, right? So in order to fix this, we can go back to the floor material and we can change its tiling. So tiling is how many times the texture is repeated per basically like unit. So if we increase the X tiling to 100, or rather 10, you can see now there's 10 copies of that texture all across the X direction. So if we change the Y to also 10, now we can see that's looking pretty good. That's not bad. So it's starting to come together. And the reason why a lot of these golf games kind of use textures like that, where it's kind of like a checkerboard, is probably so that you can see and estimate the distance that you have to go to different spots, right? Because if it was just a plain grass texture, you wouldn't be able to estimate it because you don't know the size of each of these little squares. And so it does help people play and helps people be able to play better than they would before. So that's looking pretty good. But now let's get some textures on these gray walls, right? Let's make them wood, or rather just like a brown texture. Oh. Down here in the assets view, right click that, create, and we go to material again. And now let's call this one walls. So this is the material that we're going to use for all of these walls. And over here, if we had a wood texture, we could actually use that, but we don't really need a wood texture. This is just pretty simple. So instead, we're just going to change the albedo color. We can hit that and try to find like a dark kind of brown color, just like that maybe, right? Just like that. And then we can drag this texture onto each of our walls, just like that. And you'll see it applies to all of our walls. So now look at that. We've got our walls, we've got our terrain. Now let's just add one more obstacle. Let's add that log in there so that they can't just shoot for the hole straight away, but they have to go around the log first. So if they're really good at golf, they could do a really powerful shot, bounce off the wall, maybe get it in. So it kind of creates that opportunity for, you know, cool moments instead of just doing small shots to get around things. Let's create a log. So if we right click in the hierarchy, 3D object, and let's do a cylinder, because logs are kind of like cylinders, right? And so there's our cylinder. Yeah, so we can move it back over here to kind of where we're going to put it. And then we got to change the rotation so it's on its side instead of standing up like this. So that's going to be the X rotation. Just rotate that. It's going to be 90 degrees. That's looking pretty good. Now let's extend it a little bit more. So so the plan is for them to shoot all the way out forward and then be able to be in the big open space over there. So we can just extend, not the X, but the Y rather, because we rotated it. So instead of the Y being up and down, it's now side to side. So we can expand this to maybe 5 or so. And that's looking pretty good. My transform gizmo disappeared again. That's okay. We'll just start real quick because I think something with the terrain is making it disappear. I'll have to look more into that later, but that's okay. Okay, yeah, so we'll start over here. They'll shoot out forward and then kind of go around the side and try to get it in the volcano. And let's apply the same wall texture to the log too. And there we go. That's looking pretty good. Not bad. Cool. So now we've got to, we've completed one of our objectives today, which was to, make our level. Our level is pretty much done. And so our next objective is to, let me open up the slides again real quick. So our next objective, look at these slides. So we did a little intro, did some level design, and now it's time to get into scripting to make this thing actually work. Because right now, if you try to play the game, I'll show you how to play it right now. So if you want to play test your game within the editor, you can hit this little play button up here at the top middle. And that'll put you in the game so that you can just walk around and play it if you had if you had a walking script, because right now we don't have anything. So if we just hit the play button, we just kind of see a view. And that's what the camera sees right now at its current position. So while we're in play mode, we can actually go back to the scene tab, and you can see that our camera is right here, right? Select our camera, and it's looking outwards that way. And you can see the camera preview. That's exactly what we saw in the game view. So we don't want it to start there. We want it to start kind of over in that corner where the ball is going to be, right? Hey, Gotcha, what's up? So let's move the camera right over there into that corner, and then we'll also place our ball that we're going to be moving. Let me just restart real quick because my gizmos are gone again. That's okay. Any questions so far? Alrighty. Cool. So now we can select our main camera and drag it on over. So when you want to drag on two axes, like I want to drag on this blue axis and this red axis, you can actually select one of these faces of this kind of cube looking thing right here and move it on those two axes. So for example, if I select this green one, that's parallel to the two axes I want to move on. So if I select that, it'll just move over just like that. That makes it nice and easy. You can position it kind of right there, maybe up a little bit, and then we want to angle it down so that it's actually looking at the ball. So we can adjust the rotation for that. Just the Y rotation, oh, X rotation. So we look down and you can see in the camera preview exactly what the camera sees. So that's pretty useful. So that's looking pretty good. Now let's get the ball in there. We don't have a ball to kick around yet. So right click on the hierarchy scene, in the hierarchy view, 3D object, sphere. And let's rename this again to ball. And let's rename the cylinder while we're at it to log. Oh, and one thing I forgot from earlier when we were dealing with the gizmos, I created that empty game object. You can see it here. Because remember, I right-clicked, create empty. And so if we hit F, we can focus on it. You can see it's kind of right there. It doesn't really do anything, but we're just going to use it as a container for our level. So in case we want to move our entire level, we can just move this one game object and everything will move with it. And this is kind of like the notion of parenting. So if something is parented to another thing, you got the parent, you got the child. When the parent moves, the child will move with it. If the parent rotates, the child will rotate with it. And that's exactly what we want. So let's rename this kind of parent game object to level. And that's going to be our entire level. And let's drag this up to the top here and then select all of our stuff. So you can click that and then hold shift, click the log. We've got everything selected, but not the ball. We don't want the ball to move with the level. The ball is separate. And then we drag all of this right onto level, and you'll see it kind of indents a little bit, and that means all of these are parented to the level game object. So when I move around this game object, everything moves, and you see the ball doesn't move. And that's exactly what we want. So in case you wanted to create multiple levels, you could just have them all underneath a parent game object, so you can easily move them around, maybe animate them moving. There's a lot of cool things that you could do. So it's important to kind of understand the notion of parenting game objects. Alrighty, so now let's look at our ball. That seems a little big. So let's adjust the size a little bit. So again, that's scale. And let's try 0.2, 0.2, 0.2. We want to scale it on all axes so that it's the same, because if we didn't scale it on one axis, like let's say Z we left as 1, it kind of look like that. And I don't want to golf that. I want to golf a nice round ball. So we'll put that as 0.2. And that seems like an appropriate scale for our game. You can see the volcano is not too large. It's smaller than a log, so they have to go around it. So that should be pretty good. And now let's move it back into position, because this is going to be sort of our initial starting position for our golf game. Now let's move it right down onto the ground. And so it's kind of in the ground right now, but we want it to be exactly on top. So what was our trick for that before? Take the Y scale, 0.2, and divide it in half, and then set that as the Y position. So 0.2, divide that in half, 0.1, and now as you can see, it is perfectly on the ground, which is just what we want. Let's take another look at the camera to see if it's actually looking at the ball right now. It's looking pretty good. Let's just move it over a little bit. Maybe move the ball over too. Let's see. That's looking pretty good. Maybe move the camera back a little bit. If you go to the game scene, you can see the full screen camera view. And that's looking pretty good. I like that. You can see the ball kind of in the lower portion of it, and then you can see the rest of kind of the map in the upper. So that's looking pretty good. So now we want to design a camera system. So the camera system is how we're going to control the camera, because again, if we just play it right now, if I move my mouse, I can't move the camera. I want it to be able to move the camera as I move my mouse around. If you played basically any game, Minecraft, Fortnite, League of Legends, when you move your mouse, the camera moves. And that's what we want, so that when they move their mouse, they can go look at the hole, see what it's like, then look back, and then go in that direction. So let's work on a simple camera system. And so in order to create scripts, you can go down here into the assets and right-click, create C# script. You can also use JavaScript in Unity, but I would say the majority of people use C#, but hey, you could do whatever you like. I'll be doing C#. Once we do that, we create a script, and let's call it Camera Manager. There's our Camera Manager script. You can double-click it to open it up. And this will open it up in your default editor, whatever that might be configured to be. It might be Unity, it might be MonoDevelop, which is Unity's default, or you could open it up in Visual Studio Code as well. And you can configure the default editor up in, I believe, Edit, Preferences, External Tools, and then you can set the external script editor to one of the ones you have installed. So you can see I have Visual Studio 2019, Visual Studio Code, and 2017. So you can choose whichever one you would like to develop in. And so once we've got that open, it'll look something like this, depending on your IDE. And so this is kind of like the default script that's part of a thing in the world, mono behavior. So you can see we have some imports here from Unity, and it creates a public class with the name of our script that we just made, and it inherits from mono behavior. And mono behavior is kind of like the default class for anything that's going to exist in the game world. And it has a bunch of default methods that we can use to kind of change different aspects of the game object. And so for this first script, we are going to be creating a camera system. Let me pull up my notes real quick. Any questions? Feel free to unmute and ask, or ask them in the chat. All right. So our camera manager is going to be the most complex script we're going to be writing. Generally, camera systems are very complex, but we're going to try to keep this one somewhat simple. There's going to be some kind of crazy code in there, but that's okay. So let's start at the top here. Let's define a couple class variables that we can use throughout our class. So first, let's define a public camera main camera. Now, let me explain this a little bit. So public, of course, that means it can be accessed by anyone outside of this class, accessed and modified. And then camera is the camera class from Unity. So as you can see, if I hover over it, it says class unityengine.camera. So that corresponds to the component, the camera component, that's on that camera game object that we looked at earlier. And so we're going to hook up our camera game object to this script so that when we do main camera dot something, we can change the camera's attributes. Specifically, we might want to change, the position and rotation so that it looks different ways or it moves as we look around. And so making it public allows you to kind of access it in the Unity editor as a field. I'm going to show you that right now. So if we save this script, Camera Manager, go back to Unity, it's going to reload the scripts. It might take a couple seconds for you. And then we click on main camera, and we're going to add a component called Camera Manager. And so in this Camera Manager, actually, I think we're going to add this on the ball. Yeah. Actually, remove that component. So you can remove components by these three dots over here on the right side of a component. Click them, remove component. We're not going to add it quite there. We're going to add it on the ball. And the reason we're going to add it on the ball is we're going to hook up the camera to the ball so that as the ball moves, the camera kind of moves with it. So we're going to get the ball's position and somehow orient the camera and make the camera follow the ball as it moves. So with the ball selected, we're going to hit add component, and then we can type in camera and select our Camera Manager script. And so once we add that, you can see it has a script field that's just Camera Manager. You can double click that to open it. You can see double click opens right up. But we also have this other field called main camera, and it says none. And this is the public variable that we added. So anything that's public in a class in Unity will display in the editor just like this. And this makes it useful for hooking up other things that are already in the scene. So like the main camera, I can click and drag it right into there. Now you can see it's populated. It says main camera, camera. And so that means it's specifically getting the camera component of that main camera game object. So if we click on main camera, remember the camera component here, that's what this script is now getting. So back in our script, we now have our public camera, main camera, and we can access all of its different methods and variables and different stuff to make it do things. So that's kind of fun. So now let's define another variable. This time it's going to be the camera speed. So when the user kind of wiggles their mouse around, how fast does it go? Usually games have this as sensitivity in the options, but for our purposes, we're just going to hard code it at a certain number that feels all right. But if you go further, you make a settings menu, then you can kind of hook that up to the settings menu. So we can define it as public float camera speed, and let's give it a default value. So we can say equals 5. And if we go back to Unity again, we'll see that, oh, there's another field here, camera speed, and we can increase it or decrease it as we want. but again, the default is going to be 5. So if we just add this camera manager to another game object, it's going to be default 5, and we can change it from there. But for our purposes, let's keep it at 5. All right, now let's go back in here, and we're also going to need what's called an offset. And I'll get more into this in a little bit. But we can define it as a private variable this time because no one else needs to access it but this class. Private vector3 offset. And so we're going to be using the vector3 class, which is just like a 3D point in space or a vector, whatever you prefer. And that's just going to hold the positional data of the offset. And so this is going to represent the kind of distance between the ball and the camera's position at the start of the game. So we kind of we're going to record that and then use that to set the camera's position at any point in the game. So it kind of stays at that same distance from the ball. And again, there's tons of different ways to do camera systems, but this is just kind of a simpler one that shouldn't be too crazy. Okay, now let's get into this. So we have this method called void start by default, and that's part of the default mono behavior. And it says start is called before the first frame update. So what that means is when you play the game, all the game objects are going to have their start method called instantly. And then after that, the update method is going to be called. And it says here, update is called once per frame. So every frame, this method is called. So if you want something to be continually updating, such as the camera position, we can do it in here. And there's tons of different other methods for mono behavior that you can use, but these are just the ones that we're going to be using today, and they happen to be the defaults as well. So in start, first we want to get rid of our cursor, actually, because if you notice when we play the game, like let's just hit play right now, I can still see my cursor. I don't want to see my cursor. I want to be in the game full screen, you know? So go back over here. We can set cursor dot visible equals false. Save it. And that's just going to set the cursor to not be visible, which is what most of those, full screen games do nowadays. So if we go back to Unity, let's test our change. So if you did everything right so far, and you hit the play button, you shouldn't see your cursor. My cursor's gone. So that's working great so far. But wait, they can move their cursor out of the game window, actually. Because if you noticed, I can move my cursor down into it and then back up. And that's not quite what we want. We want to kind of stay locked in the game window. So we can do this with cursor.lockState. That's kind of if it's locked or not, and if it is locked, where is it? You can already see IntelliSense is coming up with suggestions. So we're going to use cursor lock mode dot. See 3 here. Confined, it says confine cursor to the game window. Sounds like what we want. Locked locks the cursor to the center of the game window. That sounds pretty good too. Or none, which is just what we have already. So we're going to do locked just to keep it in the center of the window at all times. And then here we're also going to get the offset, because as I mentioned earlier, we want the camera to be following the ball at a specific position / distance behind it. In order to do that, we need to record the original offset. So set offset equal to, so how do we get like a 3D distance between 2 objects? We have to compare their positions, right? And how we get their position is through their transform component. So first, we'll reference this game object. So the game object that this script is applied to. You can do that through game object, just like that. That's saying, hey, whatever game object this script is on, get that one. And then we can do dot transform. Transform is such a common component on every game object that you can just reference it easily like that. And then we can do dot position. And so the dot position that you see here is the position you see here. So you can get the X, Y, Z components of any game object's position. So we get that position, but then we want to subtract the camera's position. So you have this position minus the camera, and that's going to get you a vector, a 3D vector of the distance between them. So we can do minus, and so we want the main camera's position. So we could do main camera dot transform position. That wasn't so bad, was it? Now we've got our offset, and now we just got to use it every frame. So when the user looks around, we want the camera to rotate, but still be looking at the ball. And then when the ball moves, we want the camera to move with the ball, but kind of stay at its offset, kind of looking down at the ball. And so this is kind of complex, but we'll go through it nice and slow. So in order to get the kind of mouse movement, we just want the mouse X movement. This is going to be a simple camera system, so as you just move your mouse back and forth, the camera will move back and forth. We're not going to do any Y movement because that adds a lot more complexity to it. So let's get the horizontal change, let's call it. We can do float horizontal equals, and so Unity has a bunch of different kind of API methods to get different inputs, and the one that we're going to be using is get axis. And get axis is specifically for the mouse and potentially joystick controllers. I haven't done too much with that yet, but I assume it's similar. You can do input dot get axis, and then in here it says string axis name. It says returns the value of the virtual axis identified by axis name. So that's just going to be how much we're moving our mouse in this frame. And so the name in here is just going to be mouse X. So that's the X movement of our mouse. And then we want to multiply that by our camera speed. So we have our original mouse movement, and then we want to make it go a little bit faster, maybe a little bit slower, depending on our scenario. So right now we're going to multiply it by that camera speed variable we set earlier. So times camera speed. That's going to give us how much movement we just did in the last frame. Now we can use that to modify the camera. And so the first thing we're going to do is we're going to rotate the game object a little bit. So there's some nice methods in the transform component that we can use to our advantage. So we can reference the current game object with game object transform rotate right here, and you can see it has a very complicated description. Applies a rotation of Euler angles. Z degrees are on the z-axis, x are on the x-axis, y are on the y-axis, in that order. And rotation just gets so complex the more you go into it. So it's best not to think about it too much unless you really want to, get into it. Which, if you're into that, I would recommend it. It could be pretty fun. And so for this, we're just going to have 0, horizontal, and then 0 again. And then down here, we're going to adjust the camera's position, and we're going to make it look at the ball as well. So how we're going to do that is we're first going to calculate the sort of desired angle. And the desired angle is the angle that we just set this game object's rotation to. When we did the rotate, we're going to set it to that angle. So desired angle, game object, transform, and then you remember that description from earlier? It said Euler angles. We're going to use those. Because if you don't use those, you're going to have to use quaternions, and those are even crazier. So Euler angles dot y, and the y angle is kind of the left and right turning angle. This x is up and down, and then z is kind of like a rotation like that. And so now we're we're going to use a little bit of quaternions. You know, we can mix these two things. We can mix the Euler angles and the quaternions to kind of get to our desired effect. But we can use all these helper methods, so we don't have to do any math ourselves, which is very nice. So we can declare a quaternion rotation. This is going to be the camera's new rotation. And we can create a quaternion using this method, quaternion.Euler, and that's going to construct it using the Euler rotation. And so if this is kind of going in your head, no worries. This is the most complex part of the whole workshop. After we get through this, it's going to be smooth sailing. But it's just that camera systems are super complicated, and you know, you could spend weeks on just trying to get your camera system to work. So quaternion.Euler, and then 0, desired angle, 0. So that's going to create the quaternion using that angle from earlier. And we can use this angle to calculate the position of our camera, and then we're going to make our camera look at the ball. So we can do main camera, transform, and dot position equals the current game object that we're following, which is going to be the ball. Game object dot transform dot position minus, because we don't just want to set the camera to the ball's position. That would be like a first-person view, but we don't want that. Instead, we're going to use that rotation and our offset. And by combining those two, the offset will basically rotate around the ball as the rotation changes. And so inside these parentheses, we can do rotation times offset. And so rotation is a quaternion, offset is a vector 3, and so it's going to rotate that vector 3 around the ball, kind of like a circular orbit. And then we want to make the camera look at the ball, so we can do main camera, transform, look at. That's a nice method. It says rotates the transform so the forward vector points to the current target location. So it's going to make the camera look at the ball. And it wants a transform target. So we can get the transform on the ball, which is gameObject.transform. And that's the whole camera script. So it's few lines, but it's kind of mind-boggling, and I'm not going to get any further into camera systems in this workshop. All right, now let's go test it. See if it works. So if we go back here, our ball does indeed have the camera manager script on it. Let's see what happens. So if we hit play, we can move our mouse left and right, and we can see that it's actually working pretty well. I think the camera's angled a little bit down too much. And so if you get stuck kind of like this because the mouse is locked, you can hold escape, and then you can hit the play button again to get out of that view. So let's go to the main camera and angle it up a little bit. So instead of 27, let's do about 20 degrees for the rotation X. Let's hit play again. And well, that didn't change too much, but for our purposes, well, actually, if we want to change the angle, because the angle is determined by the look at, and it's always going to be at the center of the screen, we can actually just shift the camera down a little bit, because then it'll be a kind of steeper angle. So if we do that, you can see a little bit more. Let's just shift it down a little bit more. See what that looks like. Oh, yeah, that's looking pretty good. So I think that's pretty much it for our camera. So we can look around. And now let's dive into the next thing, which will be the ball movement. So we want to be able to choose our power and then shoot the ball forward. And so this is going to involve physics, because we want the ball to roll on the ground. We want it to hit the sides and kind of bounce off. We want it to do all sorts of different stuff. So before we begin, any questions so far? Anything you want repeated, unclear? Otherwise, we'll dive right back into it. All right. So let's go ahead and create another script. So in this script, right-click, create C# script, and let's call it Ball Manager. This is going to manage the ball. And inside of here, the script might look a little bit lengthier than the other one, but it's actually going to be somewhat simpler in concept. So at the beginning, of course, we're going to define a few variables that we're going to use and that we want to hook up to things outside of the script, just like the camera manager script. And so the first one is going to be the camera. We need that guy again. And the reason that we need the camera again is we want to get the camera's current rotation, so where it's looking, and then shoot the ball in that direction. And so we're going to get the camera's rotation and then make the ball go wherever the player is looking, because that's the direction they want to shoot. Let's declare it again, public camera, main camera. And then we also want to max speed of the ball. So how fast can it go if you do a maximum power shot? So public float, max speed. And we'll just set that in the editor, and we can adjust it as needed if it's too much, too little. And for now, that is pretty much all we need. We'll be adding some more stuff later to this script to hook it up to the UI, but that's going to be a little bit later. And so in the update function, we are just going to detect inputs. We're going to see if they pressed the launch button. And how we're going to do that is we can just check if input.get button down. So you can see here, as I'm typing it, it's coming up with suggestions. There's get button down, and get button up. And they all have their different uses. So get button returns true as it's held down. So it's like when they're holding the button. Get button down is during the first frame that they press it. So right when they press it down, they'll shoot, which is what we want. And then get button up is when they release it. So maybe they don't want to shoot yet. They're holding it down, and then they shoot. And that could be useful for maybe adjusting the power of the shot by just holding space, which could be fun too. But in this example, we're going to be using the left and right mouse buttons to actually adjust the power of the shot. So we're using get button down. And then inside here, you're going to pass in the button name. And these button names are defined by you in the project settings, and we're going to go there right after this. So we're going to call this button launch. It's going to launch our ball. So we have an if statement. If we hit the launch button, do something. And this is called every frame. So it's like a polling approach. Every frame. Do you press the launch button? Nope. Do you press the launch button? Yes. Now we're going to launch. So we want to launch ball forward. And so how we're going to do that is we need some physics. Our ball doesn't have any physics right now. It's kind of just sitting there. And so in order to add physics, we can add a component called a rigid body to the ball. And a rigid body basically just applies physics to your object. And so it makes it affected by gravity. If other objects hit it, they collide with it, and it gets pushed. You can do all sorts of different configuration to, make it move the way that you want it to move. So you want to have more mass, you want to slide across a slippery surface. All of that kind of ties into the rigid body. So click on our ball, add component. We can type in rigid body. And this is what's going to do all of that for us. And so for now, we're just going to keep all of this as is, except for constraints. So the reason that we're going to do constraints right now is because our camera system is pretty simple, and if we don't constrain it, it's going to kind of go crazy. And I can show you that in a bit. But we're going to come back to these constraints. But this is basically what the rigid body can affect the object, what different axes. So it has freeze position, freeze rotation. So if you don't want the rigid body to make the object fall over or, rotate, then you can freeze all of the rotation and it won't fall over. But otherwise, it might fall over if it gets hit by something else. And so let's go back into our script, because now that we have the rigid body component on there, we can use that component. Let's do that. I'm going to launch the ball forward. And a good method to do this is by setting its velocity. And we can only set its velocity if we have this rigid body component, because velocity is a physics calculation. So we can reference our game object with game object. And we want to get the component rigid body. So we can do dot get component. And then in these dudes, we type the name of our component, so rigid body, and then more parentheses. And now that we have the component, we can do stuff to it. So we could do dot velocity. Now we have the velocity. We want to set it to something, right? We want to set it to the camera's forward rotation, right, times some value. And that value is going to be the power. So let's try that. So we're going to be using the main camera transform dot rotation. That's wherever it's looking. And then times, we want it to go forward based on that rotation. So that would just be vector3 dot forward. And then we want to have a power, right? And we set max speed as kind of like the max power, max speed that the ball can go when we launch. And so then we just multiply it by max speed. That's it. Simple, right? Let's test it, see if it works. So back in Unity, click the ball, and let's add our new ball manager script to it. So ball manager, add that. Main camera, got to link that up before we start, otherwise it'll give errors. So we can just drag the main camera right in there. And then max speed, let's set this to, I don't know, 100? See what 100 does, right? And let's play it and see if it works. Uh-oh, we've got an error. So down here you can see errors, and if you click the console tab next to the project tab, we can see what those errors are. You can see it says argument exception, input button launch is not set up. Oh, and it's telling us how to change the input. And if you want to see where the error comes from, you can double click it and it'll open up the script to the exact line. So you can see we're trying to get the button down launch, but the button launch doesn't exist. So we got to make it. So it says use edit settings input. Okay, seems simple. So edit project settings, and we'll have a window that looks like this. We'll go to input manager. You can see here there's a drop down called axes. These are all of our inputs. And we want it to be on space. So I press space to launch. And we can just edit the existing one, jump. So jump is already space, as you can see, positive button, space. And we just have to change the name. If we didn't want to change the name, we could just change our code to use jump, but I think launch is more clear. So click on the name and then make it launch, and you'll see it updates there and there. And now let's try it. Click on play again. No errors. All right, we can move our camera around, good. Let's press space. That was too fast. That was very fast. We're out of the game bounds. So let's decrease that a little bit down here. Max speed. Let's go to 5. Hit play again. With 5 max speed, it kind of just rolls. Oh, but wait, what's the camera doing? I'm not doing that. What's happening? This is what I mentioned earlier with those constraints in our simple camera system. Because the camera system uses the ball's rotation to kind of figure out where it should be looking, as the ball rolls and rotates around, the camera switches around with it. And we don't want that to happen. And so in order to make that not happen, we have to click on the ball, go back to a rigid body, and freeze the rotation for X, Y, and Z. And this is going to make it so the ball doesn't actually roll, which, you know, isn't ideal for a golf game. But for this workshop, we have a simple camera system that relies on the ball not rolling really. And so we're just going to do that. We could additionally perhaps uncheck just keep the Y checked and see what that does. I didn't actually test that. but that might help. Let's see. If we launch the ball, does not know. Okay. Yeah, so we're going to lock all of these 3 rotations when the constraints freeze rotation. And then if we play it again, let's see if we still get that weird going back and forth camera. Press the space bar. Oh, seems pretty good. The ball definitely doesn't go as far because it's not actually rolling anymore, but that's okay. We're just making a simple thing. We can expand on it later. That's looking pretty good so far. Let's change the power back up to 30. Let's see how that looks. Space to fire, hit that wall, and it just kind of sticks there. We want to make these models bouncy too, right? If we look at that, we can kind of go up the volcano and it kind of sticks there. So that's not ideal, but again, it's a limit of our simple camera system. So let's make the walls bouncy. And so we can adjust the physics properties of other objects by using physics materials. So as you can see, each of these walls has a component called box collider, and that's the collision area of that object. And cubes just have, a cube collision. You can see the green lines, that's the collision. And so we can actually change this material on the box collider here to a new physics material that we create that'll make it bounce off the walls a little bit more, because that's kind of fun. So in our assets view, we can right click, create, and go down until we see Physic Material right here. And so once we create that, let's name it wall. With it selected, you can see in the inspector, we have dynamic friction, static friction, and bounciness. Main thing we're concerned about right now is bounciness, because we don't have to bounce off. But from physics class, dynamic friction is how much friction there is when something is moving on it. Static friction is when there's something that's, standing still, and how much it takes to push it, make it move. And so for spheres that are rolling, which ours is not, if it was rolling, that would be a tricky thing to actually kind of adjust since it's rolling, so it's not quite dynamic friction. But that's more physics that you can get into if you want. The main thing we want here is bounciness. Let's turn the bounciness up to 1 and see what that does. But we have to apply it to all of our walls first. Let's open up each of our walls, go down here to box collider, material, and choose the wall material. Do that for all of them. Cool. So now they all have that bouncy material. Let's see if it bounces off. No, hit the play again. Oh, it bounces off a lot more. That's pretty good. I like that. Look at that. Bounce off the walls. Does it bounce off the log? Nope, it gets stuck on the log. Maybe we want that as a feature, maybe we don't. Because we could just apply that wall material to the log again and it would bounce off the log. But for now, I think we'll just keep it on the walls. That's looking pretty good so far. So now, we want to actually be able to adjust the power of the ball. Instead of just having the set max power every shot, we want to be able to adjust it through some UI thing. And so the UI system in Unity is kind of complex. There's a lot of things you can really dive into, but we're just going to create something super simple today to do that. So for our purposes, in the hierarchy, let's right-click UI, and then we can create a scroll bar. Oh my gosh, what is that? What's it doing over there? So when you add 2D UI to your 3D scene, it kind of looks weird. And how you fix this is you click on your canvas right here. You click 2D up here next to shaded. You see this button. And then you click F to fit it to the frame. And now if we zoom in a little bit, you can see, oh, our scroll bar is down there in the bottom right. So let's move that to the middle. So select our scroll bar. And you can see here, this little box right here is kind of anchors and pivots, which is very useful for aligning things. So if you click that, and then this whole crazy thing pops up, this is just where it's going to be anchored. So like this is the top left corner. This is the top right corner. Let's anchor it at the bottom middle. So let's just click that. But we also want to anchor the position and height and width. And so to do that, you'll hold Alt and Shift as well, and then click that, and now you can see it goes right to the middle. That's exactly what we want. And we can close that, and we can open it up. So if we start opening these things, we can see we have a scroll bar, sliding handle, handle. If we zoom in a little bit, we can see what that is. Oh, actually, we didn't want a scroll bar. We wanted we wanted something else. We could probably use a scroll bar, actually. Let me see. No, that wouldn't be ideal. Yeah. So you can really use kind of whatever UI element you want because you can really customize them. But for this instance, we are going to use the slider. That's what it was. Yeah. So you can see that looks a little bit different. And that's what we're looking for. So again, recenter it, Shift Alt, click down there, lines down there. So if we open this up, then we can see everything. And so if we click slider and we go into the slider component over here, we can adjust the value. We can see it goes up and down. That sounds like what we want. As we click left and right on our mouse, we can adjust the power up or down, right? So that is exactly what we want. But we don't want that handle there. So we can just get rid of the handle. Handle slide area, delete it. And so now if we slide this back and forth, click on the slider, value, that's what we're sliding here. We click on that, we can slide it kind of back and forth. Cool. Now we want to look green when we power up. Click on fill area, expand it, fill. And we can change the color of the image here to green. And so now you can see as we change the value, it increases. And it doesn't quite hit the end, and that's because it used to have the slider there, so its default properties kind of make it constrained. And for the purposes of this tutorial, it would be slightly too long to kind of go into that and fix it, so this will be fine for our purposes. But it's a little bit small. So let's make it a little bit bigger. Start expanding it, hold Alt. We can kind of expand it on all the axes. And then Shift keeps the aspect ratio, so Alt and Shift. And that looks pretty good. And then again, we can go to rectangle transform, Alt Shift, put it at the bottom. And that looks pretty good. So if you go to the game view, that's what it looks like in the game. We added some UI. It's kind of cool, right? So now we need to animate this UI as we power up. And that's going to be done using a script. The same script that we used to launch the ball. Let's go back into it. Go back into the ball manager. And first we need a reference to the slider because we want to be able to adjust that slider's value as the power goes up and down. And to do that, we needed a new import. We need to using Unity Engine .ui, and that's going to give you all the UI classes. And here we can add a new public variable called slider, and we're just going to drag and drop our slider onto that so we can use it. Public slider. So the slider was that component of the UI that we just saw there. And then we're also going to have slider speed, and so the slider speed is going to be how fast you can charge up or down. We'll declare that as just a float, like float slider speed. That's looking pretty good. So now we just have to use all of this stuff that we have. So down here in start, we should probably reset the slider value to 0 in case we have it adjusted for testing. Just something good to do. So slider.value. And that's the value that I was adjusting before to kind of change it. Slider.value equals 0. And this value just goes between 0 and 1. You could see that earlier when we were adjusting it. 0 to 1, and then anything in between. And now in update, this is where it's going to get a little bit crazier. So we've got our launch. That works great. Looks good. We're actually going to modify that just a little bit. But now we want to check if they're pressing the left or mouse buttons. This is another input function. we can check for that. If input dot get mouse button, and this is going to get return true if we're currently pressing the mouse down, and we want to do it when it's held. So you hold it down, power goes up, and then if you hold down the right button, power goes down. So we'll do get mouse button down, 0. And that's going to be the left mouse button. Inside there, we're just going to add some to the slider value. Now, the slider dot value, but not 0 this time. We're going to do actually plus equals slider speed. So that's how fast the slider is going to go up every frame that this is happening. But there's a catch here. So depending on the user's frame rate when they're playing the game, this could go faster or slower. So let's say they're running at 10 frames per second. Update is called 10 times per second. And so every second, if they're holding it down, it'll go slider speed, and just keep increasing it, right? But let's say someone was running at 100 frames per second. Their slider would increase so much faster because there's so many more updates in a single second. And so to accommodate for this, Unity has this thing called delta time. And delta time is the amount of time that passed between this frame and the previous frame. And so for the 10 frame guy, it would be, a couple, like 100 milliseconds, right? The 100 frame guy, it would be much smaller. And we can multiply that times the slider speed to kind of get an adjusted / normalized value that is the same across all systems, no matter the frame rate. And so this is very important, especially for movement systems. So we can do slider speed times time dot delta time. Actually, yeah, we can see in the description here, it says the completion time in seconds since the last frame. So that's how long since the last update was called. That's super important that we also have that. And so that's just going to increase it when we press the left mouse button. Now let's copy this code and paste it. And we can change it to 1 for the right mouse button. And instead of plus equals, we could do minus equals. And that should increase and decrease it as we click the buttons. But now we want to use that slider value to adjust the power of the shot, right? So right now it's just times max speed. But instead, we can do max speed times slider.value. Because slider.value is just between 0 and 1, we're always going to get between 0% and 100% of that max speed, which is exactly what we want. So save that, and let's try it out. I'll go back into the game. Uh-oh, it's got an error. What's the error? We go into console. Object reference not set to an instance of an object. This is a very common error, and it happens when you declare like a public variable, like our slider, and then you don't assign something to it, and then you try to use it, and it doesn't exist. So in that case, we have to click on the ball. Remember, this is in the ball manager script. You can see slider has none. So all we have to do is drag the slider right onto there. And we also need a slider speed. For this, let's try 1. See how that looks. Now let's go back into the game and see if it works. No errors. Slider value is reset to 0. If I click the left mouse button, it increases. Click the right mouse button, decreases. Seems like it's working pretty well. So now let's try out the shot powers. Let's try 0. Let's try a little bit power. Didn't go too far. Let's try max power. Yeah, went pretty far. So that's exactly what we're looking for. Super simple, but it gets the job done. Let's increase the ball's max power while we're at it, right? Instead of 30, let's do 50. I want to be able to get those hole-in-ones. So now, after we're done with that, we can actually do a little bit of play testing just to see how it works, and see kind of what any bugs might be with our current systems. Let's increase that, press space, I could just keep pressing space and fly around. I could just increase max power. Oh, I'm gone. Okay, so there's something here. It doesn't reset the power after each shot, and we can shoot while we're moving. We shouldn't be able to shoot while we're moving. We should wait until we stop, then be able to adjust our power and shoot. So let's add that in our code. So back in a Visual Studio Code, or rather Visual Studio, Let's add some more stuff to our update. First, we want to check the speed. If the speed is moving, right, if the ball is moving, if there is speed, then we don't want to be able to launch or adjust the sliders. Let's do that. Now, we can get the speed by the magnitude of the velocity. And the velocity is super easy to get. We got it right here, right? Game object, get component, rigid body, velocity. Let's use that. So we float speed equals all of that dot magnitude. And that's just going to get our speed. So now we can check if our speed is within a certain range. Like if it's going slow enough, then we can shoot. No, because it might always have some sort of almost zero speed, but not quite. So we're going to give it sort of a threshold. So we can say if mathf, we're going to use a math library, abs. We're using absolute value because speed might be 0 or might be negative or might not be negative. I forget, but I'm just using this anyway. So if the absolute value of our speed is less than 0.1, so if it's going pretty slow, then we can do all of this stuff. We're going to throw all of this into our if statement, just like that. So now, only if the speed is pretty slow can we do any of this. But we also need to reset the slider value after we shoot. And that's super easy too. We do it up here, right? Slider.value equals 0. Just copy that and put it in our launch function. See the launch if statement right here. Just like that. And let's see how that looks. Now we can hit play, charge up, launch, and I can't increase speed and I can't launch either. But now I stop moving, I can launch again. Launch up the volcano. Didn't quite get there. Try it again. A little bit stuck. Go right through it. So it's a little difficult. You can fall through something sometimes, but those are just bugs that need to be worked out in the future. And the last thing that we need to do is we need to actually make it tell us that we won, right? If we get it in the volcano, pop up some text saying, hey, you won. In a future version of this game, you could make it depend on the number of strokes that it took you to get it in. So if you get it in 1 stroke, then it says hole in 1. If you get it in 2, then it would be based on, you know, the par value of that course. So birdie, par, bogey, all those different things. For our purposes, we're just going to say you won if you get it in. And that's going to be actually the last thing that we're doing for this workshop. So we want to just say you won if you get it in a certain region, because the region is going to be kind of an area in the hole. And so how we can do that is in the level. Let's switch back to 3D mode. So up here next to shaded, you see 2D. Unclick that, and then see the level. Hit F, and it'll zoom right back into the level. You can zoom in a little bit more. We want our region to be right in there, right? I think this volcano might be a little bit too steep, actually. Let me adjust it just a little bit. Let's go to here and a little bit bigger. Brush size 6 or so, and then we can do shift click again and decrease it a little bit. Yeah, you have to play with the terrain a lot to make it, you know, look exactly how you want it to, make it nice and smooth. But this is just kind of like a little intro. As you can see, it doesn't look quite that great. You have to do some blending. And there is a smooth height, actually, but it doesn't always work for the smaller things, but that's okay. So as you can see, that's our terrain. If we go back to this, our gizmos are gone again. So I'll restart real quick, and then we'll finish up this up with the last thing. Feel free to let me know if you have any questions. Apparently it doesn't want to load. Cool. Sometimes that also happens. There we go. So we're back in here. We got our smaller hill. That looks kind of weird, but that's okay. And so we want to define a region that the ball can be in, and it'll say, hey, you won. So inside our level, we can right-click level and hit create empty. And this is just going to be an invisible game object because we want to define an invisible region that'll trigger the win. So we can say whole region. Our object is kind of over there, so we can move it over here. And in order to define a region, we can use a rigid body, actually, or rather not a rigid body. We don't want physics, but we do want a collision kind of area. And so we can add a collider. There's all sorts of colliders, box collider, capsule collider. It just depends on what your object is shaped like. And so for us, we're going to do a box collider. And if we look at this, we can move it over to our hole. And it's way down there, so we can move it up and across. Let's see, just across a little bit more. It's a little bit difficult to position. There's definitely better ways to do this, but it's just one of them. And we'll just position it right in the center, lower it down a little bit, and that looks pretty good. We can increase the size slightly just to make sure they can get in the hole. There we go. So if they get in that area, then they win. So we want to detect that. And instead of this actually colliding with the ball, we just want it to trigger something. And how we do that is we do this check over here on the box collider component called isTrigger. Just check that. That's it. And so that's going to trigger something. And we can use some of the scripting methods to use that. Let's do that right now. So back in here, we actually want to go back to Unity real quick and create the hole detection script. So let's do that right now. So create C# script, and let's go name it hole detection. Open that up. And this is going to be super simple. We don't even need these guys. All we need is a method called onTriggerEnter, and that's called when another object enters that collision region. And so we can use it by defining it like this: public void onTriggerEnter. And you see it has the pop-up, and it gives it all to me. And so you get it by the collider of the other thing that it hit. But we don't want it to just collide with anything. Like if something else falls in there somehow, we don't want it to trigger, only if the ball gets in there. And so we can do that by using tags. We can assign a tag to a game object, which is kind of just a string that sort of identifies the game object. So we can check its tag, see if the tag is the ball, and then trigger the win. And there's a lot of different ways to compare different game objects and stuff, but this is just one way. So we can check if the other thing that just fell into this collider, game object, so we get the game object that fell into it. If its tag equals ball, so if this is the ball that just fell into the zone, then ball entered the region. And we can actually print this to the screen before we add the text, just to make sure it's working. So we could do debug.log ball entered region. So that's going to print if the ball enters the region. So let's test it. So we want to apply this to the whole region script, remember. So add component, hole detection. Let's try it out. See if we can get it into the region. So let's charge up like that, and then try to get it right in there. Not quite. No, we're stuck. And see, we got it into the region. Did it do anything? Let's see. Where'd the console go? What the heck? The console is apparently gone. That is real weird. Okay. That was strange. Okay, let's try that one more time. So launch the ball, and then we want to get it into the region. Not quite. And there is nothing detected. Why is that? We didn't give the ball the tag of ball. So it detected something, but it didn't see the tag. So it's like, I'm not going to print anything. So instead, I'm going to go to the ball game object. You can see up here at the top near the title, it says tag untagged. Let's add the ball tag. So we can go down to add tag, hit the plus right here, and call it ball. And so now our ball can have the ball tag. So let's try that one more time and see if we get the print. That. Charge up. Nope, not quite. Got stuck. Not quite. It was right in there. And as you can see, it says ball entered region. Perfect. That's exactly what we're looking for. So now, to conclude, we're just going to make some quick text that's going to just appear on the screen saying, you win. So let's do that right now in our UI system. So in our canvas, we can right-click it and go to UI and text, because this is going to be text. And of course, switch to 2D mode up here. Hit F, reframe, and scroll out. There's our text. So it looks pretty ugly though, right? So that's why I included that font in the workshop resources as well. And so if we go ahead and download that font, it's the adventure.otf. We can use that to make our win text look much better. So just downloaded it. Let's drag it right in there. And there it is, adventure. So now in the text, instead of using font Arial, we hit this little thing and choose adventure. And let's change the font size to 50. And it's cut off. So in here, in the rect transform, click this thing again. And then down here in the bottom right, we want to expand the entire window. So let's hold Alt and Shift, click that, and there it is. And then we can go to paragraph down here, alignment, middle, middle, and now it's right in the middle of the screen, which is just what we want. We can make it a little bit bigger. And let's change the color to red. And let's change the text to you win. Let's change the color. You can see color right here. Change that, maybe like an orangish. There we go. That looks pretty good. Let's add a stroke around the edges, a little outline, so that it kind of contrasts with the background. So we can add component, stroke. Actually, it's rather called outline. You can see there's an outline now. And let's just increase the effect. This is 2, -2. If we click on effect color, you can see the alpha channel here. It's halfway transparent, so 50% transparent. We can actually increase that to 100%. Nice, thick outline. Perfect. So we're just going to make that appear when they get the ball in the hole. Let's do it. So get out of 2D mode, go back to the level, and let's go back into our hole detection script. So right in here, first we need the text. We can just get the general game object here, because we're going to just set the game object active or not active. If it's not active, it'll be invisible. If it's active, it'll be visible. So we can specify public game object text. And that's the game object that has the text on it. And then when we enter the region, instead of logging it, let's do text.setActive true. So that's just going to make the text appear when we enter the region. And so going back into Unity, we want to hide the text first. We don't want it to be showing at the beginning of the game, because if you go to the game view, you win is already there. They didn't win yet. So you just select it, and then this check mark next to the name, that's what sets it active or inactive. So if we just uncheck it, it disappears. As you can see, it's not there anymore. And so one last thing before we actually try it out, in the hole detection, if we click on the whole region and we see the script here, it's waiting for the text game object. So we can just drag this right in there. And that's pretty much it. So if we go ahead and play our game, charge up, fire. Let's try to get it in. Charge up, fire. Just over. Just over. Oh, it's stuck. Let's try to get it right in there. Nope. The terrain is a little wonky. Actually, I think it just got stuck. But once we get it in, we should see that text appear. Nope. Gonna hit it at just the right angle. Let's try it again. Oop, not quite. Yeah, so this is the movement is due to some of our camera limitations and that freezing rotation. Generally, we would spend more time on this, but we don't have quite enough. So as you can see, we got it in. It says you win. And that's pretty much it for this Unity tutorial. I hope you learned something. Now you can see kind of how to make those golf games that you see on Steam. It's not too bad, really. This is what we did in about 2 hours from scratch. And so with more time, you could, make the terrain look better, fix the camera, add some more things, add more levels, and all sorts of stuff. So that concludes this workshop. Thanks for coming. I'll stick here for just a couple more minutes if you have extra questions or want to learn more. So thanks for coming to the workshop.